A quadratic equation is a fundamental concept in algebra. It is defined as an equation of the specific form ax squared plus bx plus c equals 0, where a, b, and c are constants, and importantly, a is not equal to 0. But why are these equations called quadratic? The term comes from the Latin word quadratus, meaning square. This is because the highest power of the variable x in the equation is 2, which represents x squared. Let's look at some concrete examples of quadratic equations. Here we have x squared minus 4 equals 0, which is a simple quadratic. We also have 2x squared plus 3x minus 5 equals 0, showing all three terms. And x squared equals 9, which is another common form. Solving a quadratic equation means finding the values of x that make the equation true. These values are called the roots or solutions of the equation. When we substitute these values back into the original equation, both sides become equal. Quadratic equations can have different types of solutions. They may have two distinct real solutions, one repeated real solution, or two complex solutions that are not real numbers. The type of solution depends on the specific values of the coefficients a, b, and c. We can visualize quadratic equations using graphs. The graph of a quadratic equation is always a parabola. The solutions to the quadratic equation correspond to the x-intercepts of this parabola, the points where the curve crosses the x-axis. Bhaskara's formula, also known as the quadratic formula, is one of the most important tools in algebra. This powerful formula gives us a direct method to solve any quadratic equation. To use this formula, we first need to identify the coefficients a, b, and c from our quadratic equation. Let's see how this works with a specific example. The discriminant is a crucial part of the quadratic formula. It's the expression under the square root sign, and it tells us important information about the nature of our solutions. The discriminant can have three different outcomes, each telling us something different about our solutions. Let's examine each case carefully. The plus-minus symbol in the quadratic formula is what gives us two solutions. Let's see how this works by splitting the formula into its two parts. Finally, it's crucial to substitute the values correctly and simplify carefully. Small errors in substitution or arithmetic can lead to completely wrong answers, so always double-check your work.